Welcome, class! Let's learn part 2, number 1. Any questions before we start? Yes.
I really like your frown.
Thank you. I'm
It's gorgeous.
Yes.
Well, before we start, I'd like to tell a joke.
Okay.
Okay, so Hydrogen walks into a bar,
Oh, okay.
and the bartender doesn't serve him, and Hydrogen doesn't react. Yeah, anyway.
Okay. We're going to start. Okay. So, to solve this problem... I know! I know how to solve it! Yeah. Yes. Would you like to come up and solve it for me? Okay. Okay. Well, class, there is... Okay, so since it's 2H2, there are 2 H bonds. So it's 2 times 4, 36. Plus, and since it's O2, there's one double O bond plus 499, and then you subtract 2H2O, so 2 times 2 OH bonds, so it's 4 actually, times 463, and then you get negative 481 kilojoules per mole. That's because I know everything. I have a question. Yes. What is H? What is H? Okay. Well, what is H? That is a good question. Can anyone answer that? I can answer it. I can draw it with my body. Should I just see?
Draw with your body.
Anyway, H is a letter in the alphabet, but it's also in chemistry it stands for hydrogen, which you should know because you. Good job. I don't think that's the H we're talking about. What is delta H? Oh, I know. Yes.
Of course she does.
Of course, yes. The delta H is whether a reaction is endothermic or exothermic. Yay!
Yay! What class is this?
This is Chemistry 101. Okay. So, to continue on. I know everything. Was that reaction endothermic or exothermic?
I don't know.
Yes, it was. Wait, it was since delta H was negative, therefore it was exothermic. Good job. What?
Oh, I know.
Yes.
It says exothermic. It exposes by your hair today.
Teachers, okay, I like your hair.
Thank you.
I like your clothes too.
Thank you. Okay. What does this enthalpy value tell you about the bond energies of the products versus the reactants? Please clearly. Yes, Brooke. I can repeat the question. What does the enthalpy value tell you about the bond energies of the products versus the reactants? Okay, well, since it's negative and since the equation is the reactants minus the products, therefore the products must have more bond energies. Yay!
Wait, I have a question!
Yes.
What is a bond?
Okay. Now it's time for an example. Okay. So, a bond is like when you have a calculator and a calculator case and they're bonded together.
Oh, teacher, that's such an amazing example. You're so smart.
Thank you. Okay, moving on. How do we predict the algebraic value of the entropy change, delta S, for this reaction? Anyone know? Yes, Brooke. I know everything. Okay. because whenever we know that since delta H is negative, and we know that if like delta H is negative, we know that delta H is negative, and so and delta S, what is delta S? Oh, it creates less disorder because it goes from 2 gases to 1 liquid. Good job. Okay. That was good. Any questions? Yes.
Can I go to the bathroom? I know. Look what you did. Did a dog die in here or something? What is that noise?
I think it's Anyway, moving on, class. Let's get on target. Okay. So, please, moving forward, describe the conditions where this reaction is thermodynamically favorable or spontaneous. Explain, please. Yes.
What does spontaneous mean?
I know.
Yes.
Okay, we know this is spontaneous when the temperature is going down because delta S and delta H are both negative. So when delta G is negative, the temperature is going down.
Pay attention.
Oh my god.
That was very excellent. That was a good explanation.
Is it time for class yet?
Teacher Grace.
That one. That one's a bit challenging for you guys. You guys really aren't at that level yet. So.
I think we're done.
Are you calling us stupid?
Oh no.
Stop calling me stupid. I'm the best.
All right. I think that's a wrap.